Happy snow day, AAF. We are pretty crunched for time to finish the end of this semester and get our unit test in, so I want to make sure that we can move on. So please pass this along. I'm going to have this video sent to you through Canvas email, but if you don't, some of your friends maybe don't get it in either myself or Ms. Petulante's class, please make sure that you try to pass on this information. And now you'll feel just like my calculus kids. My calculus kids always get a video on snow days. Alright, so this warm-up, notice first that your homework is partly in the book and a handout. Now the handout will be visible on our Canvas site, and it's called Write Your Own Equation, and the book pages I will have to send you a separate email with those, since I assume most of you will have your book at home, but some of you may not, so I'm going to try to upload a picture of them. I don't know if I'll be successful, but I'll try. Anyway, so let's start with this warm-up. This warm-up has a great quiz question here, or an assessment question to start off with, because I can test a lot of objectives here and not a lot of work, right? I should put a heart around here, right? I can get a lot of things and tell by your answer this whether you understand what an odd degree function looks like, if you know the effect of a negative leading coefficient on the end behavior, if you understand what a normal root is, which I have that in air quotes, which means it's one of my words, so I'll tell you what that means in a minute, to be real, what a double root means, and what having no other real roots means. So I can answer all of those questions, or I can see the answer to all of those questions in a simple sketch. Now when it says sketch, it doesn't say graph. That means I don't need any labels, no numbers, no equation, just a sketch. So let me take this apart piece by piece. In other words, I'm going to factor this problem. 7th degree polynomial means that the ends do the opposite things. Ends behave in an opposite fashion. Negative leading coefficient means that the left end goes up and the right end goes down. A normal real root means an x-intercept where you cross the x-axis. A double root counts twice for x-intercepts. It's technically 2 x-intercepts, but either sits or hangs from the x-axis. Also, there's an assumption that I'm making and that I want you to make for any assessment here. In order for me to tell you have a 7th degree, after all, you remember, a 7th degree doesn't have to have any turning points. The assumption is here just like I did in that homework for a couple days ago, that when I sketch the problems, I sketch the graphs, you will sketch the most turning points possible. So with a 7th degree, how many turning points does it have? Right? Now, without a sketch, I can already answer this question. And remember, when I write end behavior, you have to write it, right? You must use that math language I showed you. I guess I should say formal. Remember, the domain of any polynomial is negative infinity to infinity. So I'm going to write as the domain approaches the left end, and as the domain approaches the right end, the range approaches something. And I already answered that question up here. The left end for a 7th degree polynomial with a negative leading coefficient, the range goes up, but as x approaches the right end of the domain, the range goes down. That's opposite behavior, which of course is a distinguishing feature of an odd degree polynomial, right? An even degree polynomial has the same behavior on the ends. Alright, I still haven't gotten to my sketch. I'm going to put my sketch here. And then I'll erase it, so I have room for the rest of the warm-up. Now I'm going to give you there's a whole bunch of things I'm testing here, so this is going to be worth a decent amount of points, so be somewhat careful, right? Start up here. I have to have one double root, so I might as well, I'll get that, my choice, I'll get that done right away. There's my double root. Then I have to cross. This is a normal root because it crosses the x-axis rather than just sits there. And now I can't have any other roots, but I've got 2 turning points. How many am I supposed to have? 6. So I have to turn, but I can't go back up to the x-axis. So I'm going to turn, so that's 1, 2, 3, 4, 5, 6. Right? Let me count just to make sure. Right? 1, 2, 3, 4, 5, 6 turning points, a double, and a normal root. And remember, a 7th degree has how many solutions, right? Since it's a 7th degree, there are 7 solutions. How many are this? Remember, a double counts twice, and this is once, so I have 3 real solutions. Therefore, how many non-real? That's right, 4, because I have to add to 7. And remember, non-real solutions always come in pairs, so you're always going to have an even number. Make sure you don't make this graph look vertical anywhere, right? Because then you're not a function. Alright, now I'm going to erase that so I have room for the other ones. Write the equation of a cubic function that has zeros, and remember that's also roots, that's also solutions, and since each of these numbers is real, these are also x-intercepts. So write the equation of a cubic function. So I'm going to write polynomial degree 3, and since I have 3 zeros, I know how to turn zeros into linear factors. And I'm going to put 5 here and 2 there, and what am I going to put here? That's right, 0, so couldn't I have actually written this as x times x minus 2 times x minus 5? Did anybody ask you to multiply this out? No. So you can multiply this out if you want, but if I just say write an equation, you can save yourself some assessment time and just leave it in this form. Of course, as long as you do have an equation. Now this is a trick question, because it depends. End behavior, now I know it's cubic, so it's third degree, therefore the ends behave in an opposite fashion. But what's my dilation factor? My dilation factor is 1, but did it have to be? I didn't say. So what if I chose to make this negative 14, my dilation factor? My end behavior would be the left I would go up, and to the right I would go down. But of course, if I just left my dilation factor as a 1, positive 1, then on the left end I would go down, and on the right end I would go up. Now, notice there is no calculator allowed, but I'm still asking you to find all the roots. I promised you that if you are finding all the roots, which means real and not real, you would have a calculator or a graph to start with, so that you could have one real one and then use division to find the other ones. So this looks like Ms. Getz has lied to you. Well, what is the degree of this? It is not a quadratic. It's an x squared times an x squared, which is in x to the 4th. So this is a 4th degree, which means how many solutions or roots are there? That's right, there must be 4. How do I find roots? Well, I know you were using division, right? But division was for when you couldn't, what? Good F word. You always try to factor first, right? And when you find roots, you are equal to 0, aren't you? So let's take this equation and set it equal to 0. How many factors do you have? 1. 2 things are multiplied together to generate 0. Therefore, either x squared minus 10x plus 9 must be equal to 0, or x squared minus 4 must be equal to 0. How many solutions did I get? 1, 2, 3, and 4. No calculator necessary. So I might do this to you. I might say find all the roots and be on a non-calculator portion. You better think factor instead of dividing. Right? If you have to divide, I will give you either a picture of the graph, at least one real 0 to start with, or a calculator for you to find the 0, and I promised you that the zeros this year will always be integers whenever you're looking on your calculator. Alright, let's go to the lesson. The lesson today has 2 objectives. The first one is related to writing your equation, and that's what this handout is about. Writing your own equation can be very simple, right? Take the zeros, turn them into linear factors. Done. However, check out this little twist. So this should be in your notes. write your own equation, meaning there might be more than one right answer. Write an example of a cubic function, which means degree 3, which means there are 3 zeros. Uh-oh, this is the dagger. Standard form is not factored form. Remember, they might say standard or general. It means you have to multiply out your factors. Okay, so I'm going to write polynomial, degree 3, is dilation factor x minus, x minus, x minus. And I'm going to fill in the zeros they gave me. I can make my dilation factor anything I want. That's where the different answers come in. So most people just leave the dilation factor as 1, but you don't have to. So I'm going to use 1 here, and I'm going to put 2 plus I here, and you can distribute that negative if you want. I generally don't. Uh-oh. Hey! I know there has to be 3 zeros because I'm a third degree. There has to be, by theorem, 3 zeros. Oh, this is a non-real zero. What did I tell you about non-real zeros? They always come in what? Pairs. That's a test to see if you know that. So this has to be a rubric point, right? I have written an equation of a cubic function with the 3 zeros, even the hidden one, but I have not yet put it into standard form. I suggest that when you multiply these out, this is my suggestion only, you don't have to follow it if you don't want, I suggest that you multiply these 2 first. And when you multiply, you follow the rules of multiplication of binomials. X times a negative thing is negative x times that thing. X times a negative other thing is negative x times that thing. A negative thing times a negative other thing is a positive. I recognize that pattern. That's my complex conjugate, right? Which is always 4, or a squared plus b squared. So this is 4 plus 1, or 5, plus. This is negative 2x minus xi. This is negative 2x plus xi. And looky what happens, my i's disappeared. And I just have minus, minus 4x, and then of course I still have this x squared. And then I still have my third factor, so I now need to distribute 1, 2, 3 times. X cubed minus 4x squared plus 5x, and then 1, 2, 3 times. combine like terms. There's my third degree polynomial. No i's, you don't see any i's in there, which you should, right? That should make sense to you, because what we'd done before is I gave you this problem and said, with a real zero of 1, divide to find the non-real zeros, right? So you would take x minus 1, and you would and you would divide it into x cubed minus 5x squared plus 9x minus 5, and when you did, guess what you would get on top? You would get x squared minus 4x plus 5. Then you would use the quadratic formula, and when you did, guess what you would get? OMG. So again, the key to that question, oh, I forgot that I wrote all this out. Well, this will be nice, right? You can see it nicer than my writing. There we go. How does it have plus 9x? I have plus 9x and it has plus 10x. What do I do? Where'd I go? Minus 4x squared all plus 9x plus 5x. Where did I get plus 5x from? That's plus 4x and plus 5x. Oh, I think that one's wrong, right? I don't know. I'll leave that for you to figure out which one I did. Alright. How about this one? You try this one. I want you to maybe pause the video and try this. Now notice this one, this time I used general form. General and standard mean the same thing. Since this is cubic, and that's why in the warm-up I didn't have this, because I want you to know, I want you to read the directions. Don't take time to multiply something out unless they make you. This time I gave you both. I gave you all three. That's going to cancel out, right? This is right? And I'm going to get negative I squared, which of course is going to be plus 1. And in general form, the x squared term needs to come before the linear term. Ah! And there you go. Alright, so that was objective 1 in the handout. Is the handout that I'm going to give you is that you're going to download is on these problems. One of them has a fraction in it. Practice that. Don't give up. Don't stop. Practice, because on the assessment I could give you one with a fraction. You know how to do it with integers. That means you can do the distribution and the combination with fractions. It just takes you longer. Practice. Okay, this is objective 2 for today. Long division with remainders. I want you to recall from elementary school what happens when you divide by something that's not a factor. So for example, 32 is not a factor of 409. I'm just telling you that. Look what happens when I divide. Oops. I take 32, it fits into 41, I multiply 1 times 32, I add the opposite, and I get 89, and I'm going to say maybe 2, right, and get 2 times 32 is 64, and I get 25, which is smaller than what I'm dividing by. So I have to stop dividing and say that I don't have any more room to fit a 32 in. So my remainder is 25. And there were a couple of different ways that you were told to write that in elementary school. Sometimes, right, you just did R25, right? Then somebody said, well, actually, what you should do is add, this is 12 plus 25 out of what were you dividing by, right? And then we generally have dropped the adding sign. We understand that then this is the only case where an operation is not written and we assume addition, not multiplication, that I can think of, right? When somebody says 2xy and they say x is 12 and y is 25 over 32, you would multiply 12 and 25 over 32, right? Here you need to understand there is really a plus sign in there. And of course, how do you undo division? You multiply, right? What is 32 times 12 and 25 over 32? Well, what's 32 times 12? Let's take a minute and do 32 times 12. And then you multiply 32 times that fraction. Shocker, what is 384 plus 25? If this process works for numbers, guess what it also has to work for? So, this part you need to write down. Firstly, I am giving you x minus 3 is not a factor of this cubic, which means, in my thought bubble, the graph of negative 2x squared, x cubed, does not have an x-intercept. At 3. Remember, x-intercept, linear factor. They are related. So if x minus 3 is not a factor, that doesn't mean I can't divide. It just means when I divide, I'm not going to get the other factors. But I am going to divide. Right? So this problem is this is the same cubic from the warm-up the last couple of days, right? You saw that its x-intercept was negative 2. It did not cross the x-axis at 3. So what happens when we divide? I expect to get a remainder because it's not a factor. If it was a factor, remember we divided by x plus 2, which was a factor. We got a remainder, but what was the remainder? 0. If your remainder is 0, then you were dividing by a factor. If your remainder is not 0, whoops, and I'm not going to get a remainder that's 0, I already know I'm not going to get a remainder of 0. My remainder is going to be negative 25. Now, I didn't know that. I just knew my remainder wasn't 0. So let's see if I can get negative 25. How many times what do you multiply x by to get negative 2x cubed? I like to add the opposite. What do I multiply x by to get negative 4x squared? What do I multiply x by to get negative 5x? I know x minus 3 is not a factor of whatever I was dividing into, so I certainly don't keep dividing with this. The question is, though, so I have to stop. Right? Over here, didn't I stop when my remainder was 25? I stopped dividing, right? I stopped dividing, but what did I do with my remainder? For my answer was not 12. How many times does 32 fit into 409? 12 and 25 left over out of the 32 I was dividing by. So how do you think you end this problem? X minus 3 fit into this cubic. Negative 2x squared minus 4x minus 5 times. And what? Negative 25 out of what you were dividing by. What were you dividing by? That's right. Just like with numbers. 32 is not a factor of 409, therefore when you divide, you get an integer and a rational expression. Since x minus 3 is not a factor of this cubic, you get a quadratic and a remainder that is a rational expression. It's the same. So, thoughts? Using long division of polynomial functions, I can find all the zeros, real and non-real, of a polynomial function. But for now, which will be true for this year, you need to be given at least one real zero to start. I will either give you a graph or a calculator so you can graph and find the zero. Your remainder will always be 0 because this one real zero is turned into a linear factor, and when you divide with factors, your remainder is 0. But if you just want to divide because somebody told you to divide, you might get a remainder that is 0, you might not. Now I need you to realize that division can be written a couple of different ways, right? Don't you understand? You certainly understand this means divide 3 into 231, but you need to know this is actually division 2, right? I say that because you're going to be given problems like that. That is a division problem. You need to take this problem and turn it into a division problem. Now, when I divide, nobody has given me any information about x plus 1. I will definitely get a remainder. Maybe my remainder will be 0. Maybe not. Regardless, the directions were just divide. So I divide once. Nobody asked me to find all the zeros. They just said divide. Those are my instructions. So how many times does x fit into or what do I multiply x by to get x squared, x cubed, x squared. What do I multiply x by to get 2x squared? Right? My remainder is not 0. That's okay. Don't worry. Right? What does it mean, though? What conclusion can I make? Whoops, sorry. That's okay. It just means x plus 1 was not a factor. Of course, nobody asked me that, though. You're not done. What is your answer from dividing? The answer is x squared plus 2x and what? The remainder on top of what you were dividing by. This is my answer. Now, one last thing before we go. If my answer, let me rewrite my answer. If my answer to division was x squared plus 2x and negative 1 over x plus 1, how can I check my work? What is the inverse operation to division? Multiply. So, is it true that x plus 1 times x squared plus 2x, and yes, of course, some people will ask me, can I write that as minus 1 over x plus 1? Absolutely. What is this multiplication? X cubed plus 2x squared plus x plus 1 times negative 1 over x plus 1. That's what this multiplication is. I'm sorry, x. But I don't want to do the x. I want to show you, because obviously you can kind of see where I'm going there, right? I want to show you that another way I can think of, instead of taking just x and x and then the 1, take x plus 1 and multiply it 3 times. So x plus 1 times x squared, and x plus 1 times 2x, and x plus 1 times negative 1 over x plus 1. Can you see why I'd want to do it this way this time? Right? Yes, this is x cubed plus x squared, and this is 2x squared plus 2x, but what is this? Negative 1. So I am going to just do negative 1 here, and then combining like terms, of course, gets me x cubed plus 3x squared plus 2x minus 1. Ta-da! Okay, so that is the lesson for today. Again, please do look at the homework on the warm-up slide. Print out the worksheet from Canvas from our MCPS classroom site, and then your bookwork. Again, most of you have, a decent of you have the book. Please do your social media thing and send around pictures of it to people who don't have it. I will see if I have a book here somewhere, and if I can get a picture out, I will. Otherwise, see you tomorrow.